Good morning, happy Tuesday. Today we'll be doing another lesson.
Honors Math 9. All right, today's lesson 5.4, we're going to do graphs of exponential functions. So exponential functions are when the variables up in the exponent, and we have graphed linear functions, quadratic functions, absolute value functions. So this is just another type of graph to another type of function to graph. So what is an exponential function? An exponential function is a function of the form y is equal to a times b to the power of x. And remember, all the time, 0a is the y-intercept. A can't be 0. B has to be bigger than 0. B cannot be equal to 1. And x is a real number. Because we've talked about imaginary numbers, the number I so far this year. Awesome. All right, so let me show you what exponential functions look like. So here are some examples. Our first one, y is equal to 2 to the power of x. In this case, our a terms are 1, a b term is 2, and there's our x. We could have f of x is equal to negative 3 to the power of x. This time our a value is negative 1, our b value is 3, and x is in the exponent. And then we have g of t, which is 1/2 to the power of t. Again, our a value is 1, b value is 1/2, and our letter t up in the exponents. So when we do these exponential graphs are best created with a table of values. Okay, so exponential functions graphs are best created if you use a table of values. Before, when we did quadratics, we did the vertex, the x-intercepts, the y-intercepts, and the reflection point. We came up with 5 points. When we graph a line, we usually graph the y-intercept and the slope, or a point and a slope. This time, we're going to make a table of values. All right, so our first example. And I know we don't have great graph paper available, but we're just going to try and make what do. So we have y is equal to 2 to the power of x. Okay, so I'm going to make a t-chart, x, y. And I usually start off negative 2 to 2. Okay, when I plug negative 2 in for x, I have 2 to the power of negative 2, which remember is 1 over 2 squared, which is 4, 1/4. Then it's 1/2. Anything to the power of 0 is 1. Then we have 2 and 4. And you notice here, these numbers are going to get smaller and smaller and smaller and closer to 0. So let's go ahead and do a quick sketch of the graph. Again, not ideal, but we'll just see what's going on. So negative 2 is 1/4, 1/2, 0, 1, 1, 2, 2, 4. They have arrow caps in both directions. And again, this side is going to get closer and closer to 0, but it's never actually going to be 0. So let's talk about domain and range. Domain, we can plug in positive, we can plug in negative, and we can plug in 0. So the domain is negative infinity to infinity, or all real numbers. Your range, we're starting really, really close to 0 and going in the positive direction. And then we have to determine, is this function increasing or decreasing? As we travel from left to right, are we walking uphill or downhill? We are walking uphill, so this is increasing. And there you go. That's it. So this is considered exponential growth because our b value is bigger than 1. Awesome. Let's try another example. Example 2. and this is our last example for today. Nice quick lesson. We have f of x is equal to 1/3 to the power of x. Again, I'm going to make a t-chart from -2 to 2. It's a good starting point. Again, you can always add number to these t-charts, but -2 to 2 is a good place to start. I'm going to start at 0, and this becomes 0. 0 times 1 is, this to the power of 0 is 1. 1 times 1 is 1. Anything to the power of 1 is itself. 1/3 times 1/3 is 1/9. When we do negative, we're going to flip it. There we go. So now I'm going to do a quick sketch. Going 2 to -2. This time I have to go all the way up to 9. A little off my graph, but that's okay. -2, 9. -1, 3. 0, 1, 1/3. And obviously these are just a quick sketch of the graph because we don't have perfect graph paper. And again, you'll notice that the values are getting closer and closer and closer to 0. So again, our domain for all exponential functions is -infinity to infinity. Our range is 0 to infinity again. It's not always 0 to infinity, just so you know. The range can sometimes be different, but the domain will always be -infinity to infinity. And is this increasing or decreasing? As we travel from left to right, are we walking uphill or downhill? Downhill, so this is a decreasing function. And this is called exponential decay because b is bigger than 0, but it's less than 1. Awesome. Nice job today.